Hi everyone, my name is Marley Procopio, and today we'll be balancing an oxidation-reduction reaction in acidic conditions. The reaction we'll be looking at is copper sulfide plus nitrate, which reacts to form the products of the copper 2 ion, nitric oxide, and hydrogen sulfate. In order to balance this equation, there are a couple of steps that need to be done. First, we need to write out the half reactions and determine what is being oxidized and what is being reduced. Then we need to balance all atoms besides hydrogen and oxygen. Once the rest of the atoms are balanced, then we balance the hydrogen and oxygen, and we are doing this since we're in acidic conditions. After that, we balance the charge in each half reaction by adding electrons, and then we multiply those half reactions so that the number of electrons are the same in each equation. Usually, this is the least common multiple between the two numbers. Finally, we add the half reactions and cancel any terms that may appear on both sides to get the final balanced equation. Let's begin. The two half reactions that we have are copper sulfide reacting to the copper 2 ion and hydrogen sulfate, and then we also have nitrate reacting to nitric oxide. Let's focus on the copper sulfide half reaction. In order to determine if it's oxidation or reduction, we need to again look at the charges of the atoms within the compounds. Starting with copper sulfide, we see that this compound is in its free state, so the overall charge of the compound is 0. The copper 2 ion is in its ion form, so it takes the charge of the ion, which in this case is a +2. Finally, looking at the hydrogen sulfate, it has an overall charge of -1. Now, looking at the individual atoms within the compounds, we see the copper is a +2 charge and the sulfur is a -2 charge to achieve the overall charge of 0. The copper ion is already given a +2 charge, and the oxygen is a -2 charge, but since there's 4 oxygen atoms, this means that the charge is a -8, and we know that hydrogen is a +1 charge, so with this information we can determine that the sulfur is a +6 charge to achieve the overall charge of the -1 for the hydrogen sulfate. Since the sulfur is getting more positive, it's losing electrons, making this the oxidation reaction. Now we need to balance the atoms. The copper and sulfur atoms are balanced, so we then look at the oxygen. We need to add 4 H2O to the reactant side to balance it, since there are 4 oxygens on the product side. Since we now have 8 hydrogens on the reactant side, we need to add 7 hydrogen atoms to the product side to balance it out. There's already a hydrogen on the product side in the hydrogen sulfate, which is why we only add 7. Finally, we need to balance the charges. The overall charge of the product side is 8, while the overall charge of the reactant side is 0. This means we have to add 8 electrons on the product side to balance the charge of the overall reaction. This will be our unbalanced half reaction, and we're going to leave it like this for right now until we balance the other half reaction. Now we're going to do the nitrate half reaction. We know that it's reduction because the copper sulfide half reaction was oxidation. However, to make sure, we can look at the charges to see if nitrogen atom is gaining or losing electrons. The overall charge of the nitrate is -1, while the overall charge of the nitric oxide is 0, since it's in its free state. The oxygen is -2, but since there are 3 oxygen atoms, the charge is -6. So the nitrogen individual charge is +5 to achieve the overall -1 charge. The nitric oxide, the nitrogen is a +2 since we know that the oxygen is a -2 to achieve the overall 0 charge. We see that nitrogen is gaining electrons as its charge becomes more negative, so we know it's reduction. Now we need to balance the atoms. The nitrogen atoms are balanced, but we need to balance the oxygen. We have to add 2 H2O to the product side to have a total of 3 oxygen atoms on the product side. Because of this, we also have to add 4 hydrogens to the reactant side, since there are now 4 hydrogen atoms on the product side. The overall charge of the product side is 0, while the overall charge of the reactant side is +3 since there's 4 positive charges from the hydrogen and then 1 minus charge from the nitrogen. We need to add 3 electrons to the reactant side to neutralize the charge, and this will give us the final unbalanced equation for this half reaction, and now we can take both unbalanced half reactions, balance their charges, and find the overall balanced reaction. In order to balance the charges of electrons between the two reactions, we need to find the least common multiple between 8 and 3, which in this case is 24. So we multiply the oxidation reaction all the way through by 3, and we multiply the reduction reaction all the way through by 8 to get the fully balanced half reactions. With the two balanced half reactions, we can now look to see if anything cancels out. We see that the electrons cancel each other out since both quantities are present in the same amount on the reactant and product side. The water will be simplified down to 4 waters present on the product side, and the hydrogens will simplify down to 11 hydrogens present on the reactant side. Now that we canceled atoms and simplified everything, we can write out the fully balanced reaction. The balanced reaction is 11 hydrogens plus 3 copper sulfides plus 8 nitrates will react to form 3 copper 2 ions plus 4 waters plus 3 hydrogen sulfates and 8 nitric oxides. Just to reiterate, we were asked to balance an equation in acidic conditions, and the equation was the copper sulfide plus nitrate reacting to form the copper 2 ion, nitric oxide, and hydrogen sulfate. And we did so by writing half reactions, balancing the atoms besides the oxygen and hydrogen, and then balancing the hydrogen and oxygen atoms. Then we balanced the charges and multiplied the half reactions to their least common multiple, and we added the half reactions and canceled out anything that was redundant in the equations, and we added those half reactions to find the final reaction. And again, our final balanced reaction was 11 hydrogens plus 3 copper sulfides plus 8 nitrates will react to form 3 copper 2 ions plus 4 waters plus 3 hydrogen sulfates and 8 nitric oxides.